Hello scientific brilliant people, how are you today? We are going to discuss about the sign conventions for mirror because these have got a lot of applications in solving the numericals. So it essentially says that there are three basic rules. The first rule says that all distances are supposed to be measured from the pole of the mirror. So suppose if this is a concave mirror and you can see that the shining surface is outside, reflecting surface is inside. Here this is a convex mirror and the reflecting surface is outside. Now this is the center of curvature and sign conventions applies for both the kind of mirrors. So suppose if this is the object and this object, this is the pole, is at some distance from the mirror, and that distance we are supposed to measure it from the pole. So the scale of the 0 is supposed to be kept over here at the pole. Now this is 5.5 centimeters. So object distance is 5.5 centimeters irrespective of plus and minus sign right now. So all distances are measured from the pole. So the scale's 0 is to be kept over here and then measured 5.5 centimeter. Still I am supposed to write down plus and minus sign. Again, if I draw the object over here, then this is the pole of the mirror. Scale 0 is to be kept at the pole, and from here this is 2.5 centimeter. So object distance, which is represented by U, is 2.5 centimeter. These all are real objects, and real objects are kept on the reflecting sides, not on the non-reflecting side. So I can't put the object over here and expect the image to form. Even I can't put the object on this side because this is the non-reflecting surface. So all distances are measured from pole. Now the second point is very important. All distances measured along the direction of incident ray are positive and vice versa. So what am I going to do is, this is the object, and now for finding the image I require the incident rays. So this is a ray which is coming out of the object and it is going towards the mirror. So all distances in this direction are now considered to be positive because along the distance, all distances along the incident rays are positive. So now in that sense this would become negative. It is because 0 of the scale is supposed to be put over here. Now we are supposed to measure in the increasing distance direction. So we are measuring the distance in this direction, whereas incident ray is in this direction. So we are measuring the distance opposite to the incident ray from pole. So that's why this distance is negative. In the same way, incident ray comes out from the object, hits the mirror like this. Now I am supposed to measure the distance by putting scale 0 over here, and the distance is always measured in increasing distance. So I am measuring the distance like 0, 1, 2, 3 in this direction, whereas the direction of the incident ray is opposite. So I am measuring the distance opposite to the direction of incident ray. So that's why this distance is also negative. Correct. Now we might be having question that, okay, if these are negative distances, then please tell us about the positive distance, right? So I'm considering a case over here. This is the concave mirror and this is center of curvature. This is pole, and I know that if an object is kept between F and P like this, then the image is formed behind the mirror somewhere over here like this. We know this. If I am asked to measure the image distance, again I must follow step number 1. All distances are measured from pole. So the 0, scale 0 would be over here. So I am measuring the distance in this way and it is approximately 3 centimeters. So I am measuring the distance in this direction. So image distance is represented by small v, that is 3 centimeter. And now since this is the object, the incident ray is like this. So incident ray like this, and I also measured the distance along this way. So this distance is positive. Object distances are always negative because objects are always kept on the reflecting side of the mirror. And on that side, the object distance measured from pole will always be opposite to the incident ray. So all object distances will be negative, right? Okay. So if you talk about this mirror or this mirror, sign conventions are same. Let's move on to the third part. All heights measured above the principal axis are positive, which means suppose this is the object and consider a case where I am getting a real image which is inverted. So this is object, this is image, and height of the object is represented by HO, height of the image is represented by HI. In the same way, we know that object is always like this, but in case of concave mirror, the image is smaller and erect on the other side of the mirror. I am going to put the scales 0 on the principal axis like this, and I am measuring the distance in the increasing order in the upward direction. So I am measuring the distance in the upward direction away from principal axis. So this distance would be positive. So height of the object is say 0.12 centimeter and I am going away from principal axis. So it is plus 2 centimeter above principal axis. Same, 0 of the scale has to be always put on the principal axis. So 0, 1, 2, it is roughly 2.3 centimeter, but in the downward direction below principal axis. So height of the image is minus 2.3 centimeter, right? Again over here, height of the object, height of the image, both would be positive as both the distances are above the principal axis, correct? So now if I measure 0 of the scale like this, so it is approximately 1 centimeter in the upward direction, height of the image is plus 1 centimeter, and this is 2 centimeters approximately, again plus 2 centimeter. So we are supposed to write down plus and minus signs while we are actually writing the datas, correct? Now one last thing that we need to talk about the sign conventions is about the focal length. So let's go back to the previous page. Since this is a concave mirror, and in concave mirror all the rays which are parallel, they meet at focus. So this is focus which is inside, correct? And now over here the focus is on the reflecting side, whereas over here if I complete the circle, this would be the focus. I'm sorry, this is center of curvature, this is focus. But anyhow, the focus remains on the reflecting surface, and here the focus remains on the non-reflecting surface. Now, if I want to measure the focal length, the scale 0 has to be kept on the pole like this, and the focal length turns out to be 2 centimeter, but I am measuring the distance in the opposite direction to the direction of incident ray. So here the focal length is minus 2 centimeter, and here scale 0 is to be kept on the pole. The focal length I am measuring in this direction, and it is same as the direction of incident ray, so the focal length is positive. So let us talk about the important conclusions that we have learned. The most important conclusion is focal length for concave mirror is always negative and focal length for convex mirror is always positive. So you might be given the questions in competitive exam that a mirror carries negative focal length. So we have to understand that it is a concave mirror, right? Then second conclusion we can draw from here is object distance. Object distances are always negative. It is because this is a concave mirror and the object is like this. Ray would be coming towards reflecting surface, whereas pole is over here. You would be measuring distance like this. So object distance is no matter concave or convex mirror, they are always negative. Real image distances, if you are dealing with real image, right, then for real image the image is inverted, and that's why height of the image will always be negative if the object is erect. So in all the cases the object are erect, but if you say that sir I am keeping the object down, then you will get the real image up. Under that situation the object height will be negative but the image height would be positive. But we always deal with these cases that object are erect and the images are inverted. So for real images height is negative, and for virtual images height of the image would always be positive, because these images are always erect like this one. Correct. So these are few important things that you should be careful about, and let us try to apply this with a mirror formula, and we'll solve one small example on the basis of mirror formula. So mirror formula is not in your derivation, its derivation is not in your syllabus. So you have to mug up like 1 upon f is equal to 1 upon v plus 1 upon u, where u is object distance, v is image distance, and f is focal length. This equation is without sign convention. Now when we are given any numerical, we have to apply sign conventions and then we have to use this equation. So let's begin with the first numerical, and before I start numericals I would like to tell my viewers that this mirror formula is applied for concave and convex mirror both. So let's solve the first numerical. Here we are given that the position of the image of an object at a distance 12 centimeter. So what is this at a distance of 12 centimeter? So we are given object distance, that is 12 centimeter, and we know that object distances are always negative. From a convex mirror of focal length 10 centimeter. So we know that focal length of a convex mirror is positive. So it is plus 10 centimeter, and I would also like to draw this situation. So here is a convex mirror, say like this, and this is C, this is F, and the object is here at a distance 10 centimeter, sorry 12 centimeter, and we are given that the focal length is 10 centimeter. Now without even solving we can just guess the answer that when the object is anywhere in the principal axis, the image is always between pole and the focus. So your answer, your image distance, that is the distance of the image from the pole, is this distance. It will be always less than 10 centimeters. So we can just guess our answer that my answer is going to be less than 10 centimeters, because all distances are anyhow measured from pole. So this to this distance would be less than 10 centimeter. Now let's apply this one in our formula. So 1 upon f is equal to 1 upon u plus 1 upon v. This is the formula for the mirrors, and which connects focal length, object distance and image distance. So I know what is this, and I need not to put unit every time because these two are given in centimeter. So I will get my answer in centimeter. So this is 1 upon minus 12. And remember, if you don't know v, we can guess our answer is going to be in positive, because from pole in this direction along the incident ray we are going to measure our answer. So my answer is going to be positive. So even though you know the answer, don't substitute this sign. So let it be plus 1 upon v only. Now this goes on that side. So 1 upon 10 plus 1 upon 12, that is equal to 1 upon v. So now 12 into 1 is 12 plus 10 into 1 is 10 upon 12 into 10 is 120. That is equal to 1 upon v. Now this is 22 by 120, that is equal to 1 by v. So if I invert, if I do the reciprocal on both sides, then the v is equal to 120 by 22 centimeter. Now let me just calculate what is the answer. 120 divided by 22 is 5.45. So as our guesses turns out to be true that this is 45 centimeter, this is our answer. And as I told you that this answer is automatically positive. We are not putting any sign, the answer is automatically positive, which means that the image is formed behind the mirror, because then and only then the image distance would be positive, right? So this is our answer, and here we go for the next numerical. Object is placed in front of a concave mirror of focal length 30 centimeters. So what am I given is, I am given focal length as minus 30 centimeter because I am dealing with concave mirror this time. Object distance is again negative, that is 60 centimeter. Now even without solving, I can just guess my answer that object is at C. Look at this distance, it is double of this one. So when object is at C, image should be at C. So my final answer should be again 60 centimeters. Correct. And since it is a real and inverted image, so I am going to get image on the same side of the object. So my answer would be minus 60 centimeters. But let us solve and let us understand this also. So this is a concave mirror. This is 60 centimeters from pole. As I told you, from pole, this is the object. So all distances are measured from pole. So I am going to measure this distance in this way. Whereas my incident ray will always come from the head of the object towards the mirror. So this distance u would be negative 60 centimeter. That's why I have written minus 60. And the image would be over here only. So the image is also formed at the same point. So from P, if I measure the image distance, it is also negative. Okay, let us apply 1 upon f is equal to 1 upon v plus 1 upon u. Correct. 1 upon minus 30 is equal to 1 upon v plus 1 upon minus 60. So this plus and minus becomes minus. So this can be written as 1 upon v minus 1 upon 60. Now this minus 1 upon 60, when it goes on this side, this is anyhow minus can be taken up, minus 1 upon 30. This minus 1 upon 60 becomes 1 upon 60 is equal to 1 upon v. Now very smartly I am going to multiply up and down by 2. So minus 2 into 1 upon 2 into 30 plus 1 upon 60 is equal to 1 upon v. So this turns out to be minus 2 by 60 plus 1 by 60 is equal to 1 by v. So solving this further, 1 by v is equal to, this is minus 2 plus 1, this is 60, minus 2 plus 1. So 1 upon v is equal to minus 1 upon 60. So v is equal to reciprocal on both sides is equal to minus 60 centimeter. Here we go. So as discussed earlier, that before even solving the numerical, you can even judge your answers. So guys, hopefully you have enjoyed the explanation, and do subscribe to my channel if you have not done so. Thank you for watching the video.